Right, so today what we'll do is we'll finish up section 4.1. Okay, and the big picture here is we're going to be solving right triangles. Okay, does anybody remember what I said earlier? What it means to solve a triangle? What do you have to find? Yep, you got to find all the angles. And what else? Oh, Stephen, what else can you find in a triangle besides the angles?
Besides the what?
So to solve a triangle means we have to find all the angles.
Yeah.
Okay, and we also have to find all the
sides, like the legs.
yeah, find all the legs. Okay, legs, hypotenuse. Okay, so we got to find the angles. We have to find the sides. Right, so in general, there's 6 things you have to find: 3 sides, 3 angles. I have to give you 3 pieces of information to start. Okay, so half the things you need to find, I'm going to already give to you. If you're dealing with a right triangle, which every problem this week will be, what's one thing you're guaranteed to already have every time? A 90-degree angle. All right, so in addition to that 90-degree angle, okay, there's 2 cases I can have you do. Okay, I can either give you a side and one of the other angles. Okay, again, that's in addition to the 90. Okay, so I'll give you a side and an angle. Or, does anybody know what else I could give you besides a side and an angle? I could give you 2 sides. What I can't do is give you 2 angles. Right? If you knew all the angles in a triangle, that wouldn't help you to figure out the size of it. Okay? For example, if this was your triangle, okay, and I take that and I make a bigger version of it, did I change any of the angles by making it bigger? No. Okay, that angle in the lower left is still the same. The one at the top is still the same. The one in the lower right is still the same. Okay, so knowing the angles, you wouldn't be able to figure out the size. Okay, so you'll always have a side and an angle, or 2 sides. Right, so for these problems, what we usually want to do is make a sketch, especially if it's a word problem. Okay, we want to make a diagram, and somewhere in that diagram is going to be a right triangle. Okay, after we make a diagram, then we're going to organize all our information in a table. Okay, the table is just so we can kind of figure out what we already know and what we need to find. Okay, so in terms of the process, there isn't really too much more we have to go over. Okay, as long as you know your trig functions from yesterday, okay, the sine, cosine, and tangent, those are the most important. That's pretty much all you need. Okay, and maybe the Pythagorean Theorem. Okay, we might use that as well. Right, I'm going to solve this triangle. So in this triangle, b is 2 and alpha is 40. Now, it is important that we draw the information they gave us in the right spot. Yesterday, we talked about what we usually use for the names of the sides and what we usually use for the letters, for the angles. Okay, so the sides are usually A, B, and C. Okay, if I know any of that information, I'll erase what I know in a second and I'll write the number in. And then we always had a name for the angle across from side A. Okay, and this is where we use a Greek letter. Does anyone remember the name of the angle across from A?
Theta.
What did you say?
Theta.
Not theta. We're actually not going to use theta in this problem, but we've used theta in the past. I think we did yesterday. Yeah? Alpha. Yep. So we always put alpha across from A. And does anyone remember the name of the angle that always goes across from B? Beta. Good. Okay, this is your diagram for solving every right triangle problem. The diagram doesn't have to be to scale. The important thing is when you label it, A is always across from alpha, B is always across from beta, and C is always the hypotenuse. All right, so what I'm going to do is erase in this diagram what I know, okay, and fill it in. Okay, so I know B is 2, and I know alpha is 40. Right, so what that does is it kind of helps me to visualize now what's opposite 40, what's adjacent to 40. Okay, some people can do that part in their head, but I think if you've got the diagram, it's easier to see what's right next to it and what's across from it. Bless you. All right, now I'm going to make a table. So in the table, what I've done is I listed the 3 sides in one column and the 3 angles in the other. In the table, I filled in everything I was given, and I put boxes around what I need to find. Right, so when I'm done here, there's three things I need to find. A, beta, and C. Right, does anybody see something here we could find pretty easily, and you really don't even need trig to do this, based on a geometry fact? Yep.
The other angle.
Yeah, we can get the other angle because we have 2 of them.
So you just add them together and subtract them by 180.
We subtract from 180. And anybody tell me what beta has to be? 50. Yeah. 40 plus 50 is 90, plus another 90. There's my 180. All right, so any question on why beta is 50? All right, now I have beta, but I'm going to forget about it for the rest of this problem. Why do you think, even though we have beta, why do you think it would be a bad idea to use beta to try to find A or C? You could, but I don't think that's not the angle I would choose to use. Yep.
Because if you use that one, they're both adjacent.
So if you use beta, you still have an opposite and an adjacent. So the 2 would be opposite and the A would be adjacent. But there's another reason why I don't want to use beta to find anything else in this problem. Yeah?
Because if you got it wrong, then you get like both of them.
Right. Okay, if we made a mistake finding beta and you use it to find A, well, guess what? Now A is wrong. Okay? So we found beta. We're done with it. We're not going to use it for the rest of this problem. Okay, so the angle we're going to focus, if we need to use one, is alpha. Okay, because that was given, so I know it's correct. All right. Now, it doesn't matter what side you find first. Okay, you can either find A or you can find C. Let's do A first. Okay, so I'm going to find A. So I'm just going to circle it so you know what I'm finding. And I'm going to use the 2 pieces of information that were given to me. I was told B is 2, and alpha is 40. So these are the 3 things that's involved in finding A. Okay? The 2 things that were given, okay? And then the thing I have to find. Okay? Any question on what I'm trying to find here, or what I'm going to use to find it? All right. So now, at this step, we have to pick a trig function. Okay? You have 3 choices. Either sine, cosine, or tangent. Okay? And the way you figure out which one you're going to use is look at the 40-degree angle and figure out the names of these 2 sides using the words opposite, adjacent, or hypotenuse. Right? So from the perspective of the 40, what side is A? That's opposite. So this side is opposite. And from the perspective of the 40, what side is the 2? That's adjacent. So now, out of sine, cosine, and tangent, there's only one trig function that has opposite and adjacent in it. Okay, what trig function has opposite and adjacent? Yeah, tangent. Okay, I closed the other one, but in the definitions from yesterday, tangent is opposite over adjacent. All right, so let's set up our equation to find A. So it's always tangent of, and you plug in your angle. Right? Or if it's sine, you'd use sine or cosine, but you always use your angle. So write your trig function, put your angle, and now tangent is opposite over adjacent. So what's going to be my fraction on the right-hand side? It's going to be what?
A over 2.
Yeah, it's going to be A over 2. Good. And now my last step is just to get A by itself. So how do we move that 2 to the other side? Yeah, multiply by 2. And that's it. Okay, we need to type that in now, but that's all we have to do to get A for this triangle. Right, now I'll just type that in on my calculator. What units do I want to make sure that I'm in? Are we in radians or degrees? Yeah, I should be in degrees. Okay, so change to degrees. And type it in just the way you see it. 2 tangent 40. Right, so A is about 1.68. .68. Okay, any question on how I got A? Right, now I want to get C. Technically, I could use the Pythagorean Theorem to get C, because I have a right triangle, and I know A and B. But 2 reasons why I think that's not a good idea. Anybody tell me why using the Pythagorean Theorem is probably not the best idea?
Because A could be wrong.
Right. Now, if A is wrong and you use it, you're going to get C wrong. Now, let's even say A is right. Why is this not the best number to use? 1.68. Yeah, it's rounded. The answer isn't really 1.68. The answer isn't even really what you see on the screen. Okay, it's a decimal that goes on forever. If you use an answer that you rounded off to find something else, then that answer is even worse in terms of accuracy. Right? So I want to find C. Okay, so I'm going to find C. And I'm going to go back to the 2 pieces of information that were given. The 2 and the 40. Okay, so the way I'm showing you how to do this, you could get one part of the problem wrong, but still get everything else right. Okay, just because you get one thing wrong doesn't mean you're going to get everything wrong. All right, so now let's find C. All right, so the only side I haven't labeled yet is C. So A was opposite, 2 was adjacent. What's C? Hypotenuse. So this time I'm focusing on everything that's circled in blue. I got to find a trig function that has adjacent and hypotenuse in it. Okay, I don't want to use opposite because that's a rounded number. Okay, so forget about A. What trig function has adjacent and hypotenuse? Wes?
Cosine?
Yeah, cosine. So it's going to be cosine of, what am I going to put right here? Cosine of what?
It's going to be C over 2.
All right, so we got to figure out that fraction on the other side. But first, what do I have to put here?
That'd be 40, right?
Yeah, that's my argument. Okay, the thing I'm taking the cosine of. Now we have to figure out the fraction. Cosine is adjacent over hypotenuse. So what's the adjacent here? 2. And the hypotenuse? C. All right, so it's 2 over C. Right, and this one, it's similar to the last one, except now you have a letter in the bottom. Before you had a letter in the top. Well, first thing we want to do here is at least get rid of this fraction. So how could I move the c to the other side? Okay, multiply by c. Okay. So we have a divided by c. We're going to undo it by multiplying by c. Okay, so now I get c cosine 40 equals 2. But now I want to put cosine 40 on the other side. So Emily, how would I move cosine 40 to the other side? We would only subtract here if this was a plus sign.
Divide.
Yeah, we want to divide. Okay, good. Divide by cosine 40. Divide by cosine 40. So we get c equals 2 divided by cosine 40. Okay, and now we'll type that in. If you look at the original problem, look at what happened. All that you really had to do was take the c and the cosine 40 and switch places. Okay? That's kind of a shortcut when you have this setup. So in the future, if we end up with a variable in the bottom, all I'm going to do is take what's in the bottom, take what's on the left, and switch them. Okay? The reason why you can do that, we just went through it. All right, so 2 divided by cosine 40. Okay, 2.61. A few things you can check for just to make sure your answers don't have anything that really stands out that's wrong with them. The biggest side should always be across from the biggest angle. The smallest side should always be across from the smallest angle. If that doesn't happen, something went wrong. Okay, another thing you can look for, in a triangle, if you add any two sides together, they have to be bigger than the third. All right? So if I add A and B, yep, that's bigger than C. B plus C is bigger than A. And A plus C is bigger than B. If you added up two sides and they weren't bigger than the third, something went wrong. Okay? So this doesn't, what I just went through, it doesn't prove these answers are right, but it at least shows me there's nothing obviously wrong with them. Okay? Okay, any questions on that? All right, if you had extra time, now what you could do is try the Pythagorean Theorem and see if these answers work. If a squared plus b squared equals c squared, then chances are you did everything correct. So that's kind of a way to double check it. Keep in mind, we rounded some answers off. So you might not get it exact. Right? In fact, if we do a squared, let's see, plus b squared, we get 6.8224, and c squared, 6.81. Right? So 6.81, 6.82, that difference is due to rounding. Okay? But since the Pythagorean theorem seemed to work, I would say we've done everything correct. Right, so that's an example where they give you a side and an angle to start with. Right, so here's, we'll do one more where they give you a side and an angle. Okay, why don't you take a second and see if you can get this one on your own. Okay, if you can't get everything, at least try to get the angle first, and then we can work together to get the sides. Okay, but if you can get the sides, let me. I'll come around and check how you're doing. All right. So what can we get first here without too much work? Well, Carter, what can we get first here? Think about what did we find? What did we get first in the last problem? We didn't really have to use any trig to do it. Focus on this right-hand column. What can we find there? Well, what's the only thing we don't know in the right-hand column? What's the name of that? Should anyone help him out?
What might be?
Alpha.
Alpha, yeah. So we can find alpha. So what do we know about all the angles in a triangle?
Well, 180.
Yeah, they have to add up to 180. So we've already used up 90 for the right angle. So then these other two would have to add up to what?
90.
90. So what angle would you have to have for alpha so when you add 20 to it? 70, yeah, good. All right, so that angle we know without really doing too much trig, but are we going to use that to do anything else? Nope, forget about that angle now that we have it. We're not going to use it for anything else. All right, now if you have trouble visualizing like opposite, adjacent, what would be a good thing to do at this point?
Sketch it.
Yeah, make a sketch. Right, so I'm going to just label what they gave me. I'm not going to label anything that I calculated. Right, so I'm going to make A6. Okay, alpha was not given. B was not given. Beta was 20. And C was not given. All right. So now, Stephen, what side do you want to find next? B or C?
B.
B. All right. So we'll find B. So I'm going to circle the side that I'm going to find, and I'm going to circle the pieces of information I'm going to use. All right. Anybody figure out what trig function you need here? Your choices are sine, cosine, or tangent. Yep, Kate.
Would it be, oh wait, I did it wrong. Would it be tangent?
Yeah, it'd be tangent. Maybe first we should label these opposite, adjacent. All right, so now our perspective in this triangle is from the top. Okay, everything is from the perspective of the angle that was given. So opposite is furthest away, adjacent is next to it, and K, pick the right function. Okay, so tangent of 20 equals, John, what goes on the other side?
I'm sorry.
For tangent 20?
Would it be 6 over B?
Be careful, tangent is opposite over adjacent.
Okay, so B over 6.
So B over 6. And Taylor, how would I move that 6 to the other side? Multiply by 6. Multiply by 6. And there's your answer for B. Okay. Did anybody type that in and get the decimal? Yeah, Kate?
2.18.
2.18. Great. And now the last side we have to find is C. Okay, so I'm going to circle what I want to find, and I'm going to circle the two things that were given. 6 and 20. Right, Wes, what trig function would I need to use to find C?
It's adjacent and hypotenuse.
Yep, I didn't label that, but I can.
Is that cosine?
That's cosine, yep. Adjacent and hypotenuse. Good. Okay, so cosine of 20. And Becca, what's that going to equal?
Like the formula?
Yeah, what's going to be the fraction on this side?
Oh, 6 over cosine 20.
Uh,
Oh, 6 over c. Sorry.
Yeah, adjacent over hypotenuse. So yep, 6 over c. And now, anybody remember the trick I said you can do when the variable's in the bottom? What's the trick to get c by itself? Yeah. You can multiply by c and then divide by cosine 20, but as Wes just pointed to me, you just switch the cosine 20 and the c. Okay, just switch places. So C is 6 over cosine 20. All right, and anybody have the decimal for that one? Oh, Bailey, do you have that one?
I don't know.
You have it? Hunter? You get it?
6.39.
6.39. Okay. Anyone else get 6.39? All right. Again, what we can do real quick, just do the Pythagorean theorem to check the answers. 6 squared plus 2.18 squared. Okay, so I'm hoping when I square 6.39, I get about that. Let's check it. Yeah, it's close. It's a little off probably because of the rounding we did. Okay, but it's close enough that I wouldn't think anything is wrong with what we did. Hey, any questions on that one? All right, so that's the type where they give you an angle and two sides, an angle and a side. Sorry. Right, this is the second type. All right, what can't we do right away here that we were able to do in the last two problems? Yeah, you can't find an angle right away. Not quickly. Okay, you're missing both angles, so you have nothing to add up and subtract from 180. But we can get C, and we can do something this time that I wasn't okay with last time. I'm okay with the Pythagorean theorem this time. How come? Because they gave me everything I'm going to plug in. Okay, if I use Pythagorean theorem, I'm not using anything that I calculated. Just 3 squared plus 2 squared equals C squared. Okay, and Austin, what's 3 squared? 9 and 2 squared?
4.
All right, so we get 9 plus 4 equals C squared. Add up 9 and 4, we get 13. Okay, and what's my last step? How about Bailey? How do I get C by itself?
13. Square root 13.
Good. Take the square root, and C is the square root of 13. Right, at this point, if they want a decimal, we can write it. If they want to leave it exact, we can just leave it as square root 13. Okay, I'll do the decimal. About 3.61. All right, now let's make our sketch and see what happens when we try to solve for alpha or beta. Okay, so we have A, alpha across from it, B, beta across from it. Right, and we have a choice. It does not matter if you find alpha first or find beta first. So Nick, what angle you want to find first? Alpha. Okay, so I'm going to circle what he wants to find, and I'm going to circle the two things that were given, the 2 and the 3. Okay. Ashley, from the perspective of alpha, what's the name of this side? Yep. So we know the opposite. And what's the name of the side on the bottom? Adjacent. Okay. And Emily, what trig function has opposite and adjacent? Tangent. Okay, so we're going to write tangent of our angle, tangent alpha, equals opposite over adjacent. Ashley just said opposite was 3. Adjacent is 2. Right, what's a little different about that? Different than anything that happened in the last two problems. We don't have the angle. Yeah, we don't know what the angle is. Usually the variable was either in the top or the bottom of the fraction. Whenever you're given two sides, the variable's always going to be the argument to the trig function. So now our goal somehow is we have to get rid of tan. Okay, and we talked about this yesterday. How do you get rid of tan? Something that will cancel tan out. Yeah? Close. I like the idea she's using a function, but not cotangent. But I can see where people would think that, because tangent and cotangent, those are cofunctions. I want you to think like inverses. Inverse tangent, yeah. So this goes back to those 6 formulas we had at the beginning of class yesterday. And what we're going to do is take the inverse tangent of each side. Okay, the verb here is take, not multiply. Some people say multiply. We can't multiply by a word, right? It's kind of like if you had this, you wouldn't say multiply both sides by the square root. You would say take the square root of what's on the left, take the square root of what's on the right. Right. So we're going to take inverse tangent of what's on the left. Just kind of squeeze it in there. Take the inverse tangent of what's on the right. And what happens is inverse tangent, regular tangent, cancel out. And I'm left with inverse tangent 3 over 2. And now I just type that in, and that's my answer. All right, let's see what we got. Second tangent, 3 divided by 2, 56.31. Okay, so 56.3.
Test, you're going to want us to go all the way that far.
So yeah, minimum of 2 decimals, yeah. Yep. All right, and now one way I could get beta is I could just add 56.31 to 90 and subtract from 180. Why we've talked about it, why is that not the best idea?
Not right.
Right. If alpha's wrong and you add it up and subtract from 180, now you just got beta wrong. Okay, so we're going to find beta, same way we just found alpha. Okay, we're going to find that, and we're going to use the 2 pieces of information that we're given. 2 and 3. Okay, so focus on everything I circled in green. What trig function am I going to use this time? Think of what 2 sides we're working with. All right, we're working with adjacent. Yep, that's one of them. And opposite. So it's tangent again. Right? But it's not going to be quite the same fraction on the other side. So it's going to be tangent of beta. And what's opposite this time?
The 2's going to be on top.
Yeah, the 2 is going to be on top. 2 is opposite. 3 is adjacent. Right? Since we're working with a different angle, it's like we've shifted our perspective. Right? So 2 is opposite, 3 is adjacent.
So it's almost kind of like cotangent.
Yeah, it's kind of like cotangent, it's kind of like flipping it. Yeah, it's that idea. And Emily, what am I going to do on both sides to get rid of tangent?
Inverse tangent.
Yep. Take the inverse tangent. What's on the left? And what's on the right? So beta is inverse tangent of 2/3. Now, once I type that in, I'm hoping that I get something that's about what, 66, 76, 86, about 33.6, somewhere around there.
6, 9.
Okay, 6.9. That's what I'm hoping I get, because I know if I add that to that, I get 90. All right, let's try it and see. Inverse tangent of 2/3. Let's try actually typing in 2/3. It's 33.69. Yep, so that looks perfect. Okay, so that's the kind of problem that's going to happen when they give you two sides to start with. Anytime they give you two sides, you're going to have to use inverse trig. If they give you a side and an angle, you'll never use inverse trig. Okay? Only use inverse trig if you need to find an angle. That's it. Hey, any question on the side-side case? All right, so the last one we'll look at, that's another side-side. I don't think we need to go through it. Is a word problem. And keep in mind, once we make a sketch here, you're not going to have to find every side and every angle. This word problem is asking for one thing. You're going to lean a ladder against a house. The ladder is 20 feet long. The angle between the ladder and the house is 17 degrees. If you lean the ladder at that angle, I want to know how high the top of the ladder will reach. Okay, how come the ladder isn't going to reach 20 feet high? It's a 20-foot ladder. Yeah, it's on an angle. Okay, the more of a slant you put it on, the less height you can reach. Right, so let's make a sketch. Okay, based on what's written in the word problem, what's one thing I definitely want to draw in my sketch? Yeah?
A ladder.
Okay, I need a ladder. Before I even have a ladder, it needs to lean against something.
Like a wall, or a house. I guess the house.
Or, yeah, the house. And the house needs to be sitting on what? The ground. Okay, so let's put in the ground. Draw our house.
That's really good.
Okay, and we've got a 20-foot ladder leaning against that house.
Now they're trying to throw it out.
Okay, about like that. Okay, so that ladder is really like the what in this triangle that I just made?
Hypotenuse.
Yeah, it's the hypotenuse. Okay, so the hypotenuse is 20. And they tell me one more thing. The angle between the ladder and the house is 17.
So that'd be that one.
Which angle is that?
Theta.
No,
No, not theta.
it's that B angle.
Well, I guess just where in the picture is it?
Well, that's one way from 9. Well, and I'm sure it's one way from
The top.
Yeah, at the top.
No. Oh, really?
It is at the top.
The house top.
Not the house and the ground. Or not the ladder and the ground. It's between the ladder and the house. Okay, so that's 17 degrees. Okay. Once I figure out what my triangle is, generally I like to draw just the triangle separate, and now we can take the house and take that out of the equation. So here's my triangle. That's 20. That's 17. What am I trying to find in this triangle? The base or the height? I'm trying to find the height. Okay, how high will the ladder reach? The ladder is going to reach to right here. I want to know how high that point is. Okay, so I'm going to try and find that. If I was finding the base, the question would say, if you measure the distance between the house and the ladder, how far away is the bottom of the ladder from the house? That, I'm not asking for that. Okay, so we don't need to find it. Okay, so there's only one thing we need to find. Don't worry about this other angle. Don't worry about the bottom side. Find this using that and that. So which trig function would I need here? Sine, cosine, or tangent? Cosine. Okay, this is adjacent. Okay, that's adjacent because it's right next to my angle, and that's hypotenuse. This bottom side is opposite. Okay, we're not using opposite at all. All right, so we're going to use cosine. Anybody tell me what my equation will be that I'll set up?
Cosine of 20 degrees, I mean 17 degrees over A over 20.
Equals A over 20. Yep. Okay, multiply each side by 20, and then we'll have our answer. So it's 20 cosine 17. And even though we're tilting the ladder at an angle, a 17-degree angle, the ladder is still going to reach pretty high. It's probably going to still reach about 19 or so feet high. So it can still reach about 19.13 feet. Okay, what angle, just kind of thinking off the top of your head, do you think it would have to be at so the ladder would only reach half as high? So it's a 20-foot ladder. Anybody have a thought what angle you'd have to put it at so it only reaches 10 feet?
45 degrees.
A 45? Yeah, most people guess a 45. But if you actually try typing that in, if you put the ladder at a 45-degree angle, you can actually still reach 14 feet high. Okay, that is a good guess. It actually turns out you'd have to put the ladder at a 60, which would not be possible in real life. But if you put the ladder at a 60-degree angle between, it would fall. Between the house and the ladder, it would only reach 10 feet high. But 45 is a good guess. And the reason why it's not a 45, if you were almost thinking like a straight line, right? You were thinking, well, 90 is straight up, 0 would be flat on the ground. I'll just think what's in the middle, 45. But that kind of thinking, that's linear. If you graph sine and cosine, are they straight lines? Anybody remember what the graph of sine looked like? Yeah, it was a wave, right? Looks like that wave by the calendar. Okay, so because it's a wave, that basically takes using common sense out of the equation, and 45 doesn't work. Right, but that's a good guess. Okay, so any questions on that? All right, so we looked at how to solve triangles with two cases, either given a side and an angle or two sides. And then we looked at a word problem where you've got to draw the diagram. Okay, on the test there will be probably one word problem and maybe 3 solving triangles. Okay, a mixture of both types. All right, so you got about 12 or so minutes left. Okay, so I'm going to give you the last 12 minutes to start the homework. Okay, it's on 255. 31 to 39 odd, 43 and 47, and 51 to 55 odd. Okay, tomorrow will be a review day, so we'll just practice everything we need for the test. And I'll also be here after school on Thursday if anybody needs to come see me for extra help.